All right, so what we're going to do today is we're going to talk about n subdivisions, but you'll notice that the equation isn't as simple as the one that we did yesterday, which had to do with 3x and 4x, which were nice and pretty triangles. But the truth is, when Riemann was doing this, it wasn't for the triangles, because we know the area of a triangle. What we're trying to do now is define the area underneath a curve, or any curve. And this is just now the next step in that process. So we're going to start with y equals 3x squared, and we want to do n subdivisions. As we're doing this, what's our first step that we have to do every single time? And yes, you can answer. I know that they're not hearing you, but it's okay. What is the answer to that? How long is that interval? It's 4. So we're going to do 4, and I'm going to divide it by n. And so then I'm going to set up my parentheses. How many blanks would I have? Right, we're going to do enough to make a pattern, dot, dot, dot. And yes, you can put the last blank on there if you want, but we're just going to leave it like that. Where is my first bar? 4 over n. And we get that because we know that the length of every one of these is 4 over n, and we're adding that to 0. So it's 0 plus 4 over n. Good? Now we're going to plug that 4 over n into the equation, but before I do so, you're going to see me write down, I got 4 over n, what's the next x value? And then, and so on. I'm going to plug it into the equation. Your equation is 3 times 4 over n, and it's squared. That's the difference from yesterday, and it definitely will change things. Then I have 3 over 4 or over 8n squared, and then I have, oh my goodness, if I can do that again, 3 times 12 over n squared, and so on. The setup of this, you'll notice, is exactly the same, right? Nothing has changed. I still had to determine the length of the interval, still had to divide by n, still had to figure out the x values, still had to plug it into the equation. Where this gets different is what we're pulling out in common, and the reason it becomes different is because we don't just have 4 over n here. I have 4 over n squared and 8 over n squared, and so on. It may help you to actually look at what this might be. And just to do so, I'm going to write it right above here. This would just be 16 over n squared. You follow that? This would be 64 over n squared. And this would be 144 over n squared. It's not necessary that you do that every time. I just want you to see it because of what's happening here. Now, give me something that you see that's in common with every single one of these. We know the 4 over n just from there. What is in common with every single term? 3. That's the easy one, right? The next thing that you might notice is that even though they're within the squareds, do you all agree that we have 4 over n that's in common with every one of those? In fact, Zach, you just brought up a great one. It's actually not 4 over n, it's 16 over n squared in every single one of these. Well, how did you get that? It's the 4 over n squared that's in common with every one of them. Okay? And if I take a 4 over n squared out of, or 16 over n squared out of every one of these, what is left behind, this may surprise you, what is left here is 1 squared. What is left in the second term is 2 squared. If you think about it, 16 times 4 is 64. And I'm going to write it as using the squareds. The next one would be 3 squared. And you could, off to the side, recognize that 16 times 9 is, in fact, 144 over n squared. So it honestly is true that what we're dealing with here is anything that was in here is now squared. So you could have written, instead, had 4 over n from here, 3, and then written it as 4 over n squared, and then recognize what's left is 1 squared, 2 squared, 3 squared, 4 squared. You see the difference? So the next piece of this, of course, is to write it as a summation. Just to multiply this out, we've got, what is that, 64 times 3? So 192 over n cubed on the outside. How do I write what's going on here on the right-hand side? How do I write that as a sigma or a summation? Exactly. As k goes from 1 to n of k squared. And so, if you can get to this point where we have it written as a sigma, you can easily see that this isn't any different than what we've been doing, right, over the last couple of days. I'm going to put 192 over n cubed. What am I going to put in the spot of the summation of k squared? You might need to look it up, but it's 1/3 n cubed plus 1/2 n squared plus 1/6 n. Great. Now what we're going to do is we're just going to simplify this, right? Just as you would expect, we're going to do 192 divided by 3. What do you notice happens with the n cubes? It should happen every single time. Every single time your first term shouldn't have any n's. So you'll know you did something right if you did that. So we have 192 divided by 3, that'd be 64, and the n cubes cancel. Plus 192 divided by 2, so that's 96. And you all recognize n squared on top, n cubed on bottom, that leaves an n in the denominator. Plus 192 divided by 6, that would be 32. And very good, over n squared. All right, here's the question of the hour. What is the exact area? Excellent. This is the exact area. All right, so now looking at your homework assignment, you're going to notice that number 20 in A, B, and C has those numbers. And you can do it, like I said at the beginning of class, you can do it just with, you know, the old method of what you were doing, okay? But we have since found n subdivisions very similar. So what I might suggest is that you start with 20D right now, work on that one, and then get your answers for A, B, and C based on that answer. Because how could I find 3 subdivisions if it was asking it in this case here with the example that we just did in class? What would I do? We would simply plug in 3 for n. If it said 6 subdivisions, then I'm going to plug 6 in for n, and so on. Okay? So, and you can leave those fractions. That's all that it is. All right? So, good luck. Your homework assignment is 22, 23. And you'll notice 22 and 23 are just more summation stuff.